Alright, today we're going to look at a problem involving an SUV trying to go up an incline. And one of the first things you need to recognize is that the way that any car, not just SUVs, go up inclines is because of friction. And this is really how cars get anywhere, unless they're going downhill, in which case they're getting a bit of an assist by gravity. But by and large, it's friction. Now, what we're looking for specifically is what type of friction we need in order to go at a constant speed. So we're looking for a constant speed. And what does this constant speed mean? Well, that means that the acceleration is 0 meters per second squared, which is going to make the problem easier than it would be otherwise. And we're looking specifically for what coefficient of friction is necessary. So I'm looking for what coefficient of friction will make this work for this SUV to get up the incline. And I've already drawn a little bit of a diagram. You can see normal force, you have a force of friction, force of gravity, and so on. But let's go ahead and make this a little bit larger. One of the key things that we need to focus on is gravity. So here is, let's just do this. I'll have my SUV is green. So I'll go ahead and make a green dot here. And for whatever reason, it's not making a very impressive green dot. There we go. And I have a force of gravity, which is going to come down. And I have also, it's probably important to bear in mind that I have this axis here that runs, let's go from here to here. I'll exaggerate it a little bit, okay? And I have another axis that runs perpendicular to that, which I'll say goes from here to there, just like so. And this is my x-axis, and this is my y-axis. Okay. So one of the first things I need to do is split up my force of gravity into its component parts. And to do that, let's just go with kind of a lighter line here. So I need to go along the y-axis, and then I need to go along the x-axis. Okay, so this will be my force of gravity in the y, this will be my force of gravity in the x. And over here, that's the angle theta, right in there. So this is force of gravity y, this is force of gravity x. And one of the things I'm going to do, just because it makes sense to me for this problem, is I'm going to make this the negative direction and this the positive direction. And I'll go ahead and make this the positive direction and this the negative direction. What that means is that the force of gravity in the x is going to be negative, and so is the force of gravity in the y. They'll be negative numbers. But they're not my only forces. So I still have a force, a normal force, which always goes perpendicular to the surface. And I also am going to have a force of friction, which will go parallel to the surface. And because I'm just trying to overcome the force of gravity, it should actually be similar in size to the force of gravity in the x, just like the normal force should be similar in size to the force of gravity in the y direction. So I have force of friction, and I have normal force. All right. The next thing that I should probably do is list some of my givens. I've already indicated that the acceleration is 0. So done. I have a mass of 2,000 kilograms. The angle is 5 degrees. Now force of gravity in the y and force of gravity in the x. I'm just going to use some trigonometry here. So I'll have the opposite, because it's in the negative direction, mg sine. I'm sorry, cosine. I'm looking at the y direction. mg cosine theta. And in the x direction, I have something very similar. It once again is heading into the negative for the x-axis. And because it's the opposite side, I use mg sine theta. Now, primarily, I'm interested in the x direction, right? I'm trying to see what is necessary, what force of friction, or coefficient of friction, I should say, is necessary to get this SUV up the incline. But I know from past experience that I'm going to need to find out this normal force first. So I go ahead and I do, step 1 will be a sum of forces in the y direction, which will be equal to 0 because I have no acceleration vertically. I identify the forces that are acting vertically, which is the force of gravity on the y and the normal force. So I just go ahead and plug in. And I solve for the normal force. So normal force is equal to the part of gravity that is pressing the SUV into the surface of the road. My next step then is to do a sum of forces in the x direction. Once again, there's no acceleration. That's one of the conditions. 0 acceleration. So then I only have to worry about the forces that are involved. I have force of gravity in the x and I have the force of friction equals 0. But I have to do a lot of substitution here. I already know what the force of gravity in the x is. It's minus mg sine theta. And the force of friction is going to be positive mu times the normal force, which I also already know, mg cosine theta, and all of that is equal to 0. Now this is where it gets very fun. We have an m in every term. We have a g in every term. So what we are left with is the opposite of the sine of the angle equals plus mu cosine of the angle equals 0. And then all that I have to do is move sine theta over to the other side. And divide by cosine. So I get mu equals the tangent, because sine divided by cosine equals tangent, which is very, very simple. Mu equals tan theta. It doesn't get any easier than that. Even after all this mess, we get this very simple solution if you don't plug in your numbers until the end. And then all we have to worry about is what is the tan of 5 degrees. And it turns out that the tangent of 5 degrees is 0.087. And what that says is that we could climb up this hill in any car, not just an SUV, in any car, on even a fairly icy day, because this is a really low coefficient of friction. So just to quickly recap, drew a diagram. I refined my diagram by doing the free body diagram. This isn't necessary, but I think it can be helpful. Listed out my givens, realized that in order to solve for what's going on with friction, I need the normal force. Okay? So I solved for the normal force so that I could plug it in when I did my sum of forces in the x direction. I waited to plug in numbers until the very end, and I solved.